Welcome to another episode. Today we are gonna do. I think it's day 12. I don't remember the day, but yeah, let's look at the question and try to solve it. So we are given a collection of stones. So basically an area of stones, and in each turn we choose two heaviest stones and smash them together. So let's say the weight of the stones is x and y. So the result of smash can be two ways. One is if they are of equal weight, it says they are completely destroyed, and if they are not, so subtract we take the difference of them. The Like, let's say the y was the heaviest stone and then x was the next heaviest stone but less than y, so we take y minus x and we insert it in the area again. So we keep doing this till there is only one stone left, or the stone or we if there is no stone left, right? So we return 0 in that case. So let's look at the example. So what they're doing here is, um, let me open this and we can go. Let me copy the array. So it's 2 7 4 1 8 1. Awesome. Oops. So what they are saying is, I take two heaviest of this array, so which is 7 and 8. So 7 and 8. So 8 is higher than 7. We take difference of it because they are not equal, right? So difference is 1. So we insert 1 here. So now my array becomes 2 1 4 1 1 1, right? Now what I can do is I can take next two heaviest, which is 2 and 4, and the difference is 2, because they are not equal. So I insert it again, which is 2 comma 1 comma, okay, I think I have extra 1 here. It's two ones here, yeah, it should be three ones here, yeah. 1 comma 1 comma 1, right? Next I take next two heaviest, which is 2 and 1, difference is 1, so my array becomes 1 comma 1 comma 1. Now I take these two, and because they are of same size they are completely destroyed, right? So I just scrap it all, and at the end I'm left with this one only. So I return 1 as the weight. So let's see how we can solve this question. um, so hmm, so one way would be, we initially sort the array, which is 1 comma 1 comma 2 comma 4 and then 7 8, and then we take the the last two elements of the array. We check if they are not equal, we subtract it and we enter 1 here, and then we sort it again. So after pushing 1 to this array, we again sort, so it again sorting will take it 1. But in this case, for each iteration I'm doing a sort, which is like sort takes n log n, right? And I'm doing a for loop for each element, so which will be n square. Can we do better? uh, I think we can. What we can do is we can make use of max heap. So max heap, what it does is it keeps everything in sorted form in descending order, right? So this is our heap, and we can always fetch top 2. We subtract it, which is 1, and when we push it back to the heap, it heapifies itself in log n time. You guys can read more on max heap when you google, there are a lot of articles. So when you insert any value into the heap, it automatically keeps them in a sorted array. Why? Because by default the heap takes a binary tree structure where a parent, in case of max heap, the parent is always greater than its child. So when we enter one element, it will always stay in sorted array. So when we have this 1 subtracted by 8 and 7, when we add it to the heap, it heapifies itself in log n, and we get this kind of array, max heap value. And then we can fetch these two top values, do the subtraction, insert it in the heap again, and then my heap would look like 1 comma 1 comma 2, right? So I think we can make use of max heap. And max heap, push, inserting and pop. So popping obviously is top, from the top is O of 1, but pushing and then it heapifies, it takes log of n. So overall the time complexity would be n log n, which is better than the one we are getting on sorting it every time. I might need to Google because I forgot the syntax of in C++ of max heap. I need a code. It's Java max heap C++. Right. So this is mean heap by default. Let's just create some mean heap. Create some max heap. Okay. So I think I can make use of this. Okay, cool. So I can easily do a push and do a top and then a pop. Awesome. So I'll iterate over the stone cell and then I will do push. Yeah. After the push is done, my max heap is ready. Now I can do while pq dot size is always greater than 1 because we need either 1 or it's 0, right? Till then we just keep fetching the top values and subtract it. So int top 1 top, then we pop, and then int top 2 is equal to top, and we do a pop, and then if is equals to top 2 is not equal to this. If they are not, we take def, which is okay, it's a max if is no, the top one will be obviously greater than top 2, and we do a pq dot push. We keep doing this. So now if pq dot size is equals 1, then in that case we return pq dot top, else we return 0 because we know that it's empty, right? Let's see. Awesome, fingers crossed. Let's run it. Awesome. So I guess the solution was clear. Like I push everything to the max heap and then I iterate till my max heap size becomes 1 or 0, right, which is greater than 1. I keep a while loop. I pick top 2 elements and I check if they are not equal, then I need to push the difference, right? If they are equal, it says it's completely destroyed, so I just destroy them. And at the end, if I check if the size was 1, so we just return a top, else we know every stone was destroyed and we just return 0. Hope you guys like this video. If so, please subscribe to my channel and like the video. Thanks everyone.